Hi friends, now we are going to discuss about Thevenin's theorem. According to statement,
any two-terminal linear bilateral network consisting of a number of voltage sources and a resistance. It can be replaced by an equivalent circuit consisting of voltage source VTH in series with a resistance. Okay, any two-terminal linear bilateral network containing a number of voltage source and resistance can be replaced. These complex network can be replaced by an equivalent circuit consisting of voltage source is in series with the resistance RTH. Okay, Thevenin's theorem explaining us as a network how complex it is not a matter. We can replace it with equivalent circuit consisting of voltage source is in series with the resistance. Okay, like that we can change. The Thevenin theorem provides us an easy way to analyze the networks. Okay, it provides an efficient way to calculate voltage and current flowing across this load resistance. Here no need to recalculate entire circuit. Okay, here Thevenin's theorem is very simple method to find out the current and voltage in load resistance. Okay, we will going to discuss step by step about Thevenin theorem. Our target is any complex network like this, any complex network, linear bilateral network, we have to reduce to simple series circuit, VTH in series with RTH. Here this is load resistance. Okay, load resistance, no need to recalculate entire circuit. Like this we will form our load resistance. We have to calculate voltage and current across this load resistance. Here VTH means okay, VTH means open circuit voltage. Okay, here if you are viewed from here, it will appear, this voltage will appear. It is a simple open circuit voltage between terminals A and B. Okay, between terminals A and B, these two. It is also called as a Thevenin's voltage. Okay, that's why we are giving nomenclature VTH. Okay, VTH is the Thevenin's voltage. VTH open circuit voltage between terminal A and B. It is also called as a Thevenin's voltage. Here RTH is there na, RTH means that is equivalent network resistance. Okay, equivalent network resistance viewed from terminal A and B. Okay, at the time we have to replace voltage source with internal resistance. If current source is present, you have to keep open that source. Okay, RTH means equivalent resistance network as seen from the terminal A and B. At the time we have to replace entire voltage source, all voltage sources replaced with internal resistance if source kept open. Here RL, this RL means load resistance. Now to determine the current through the load resistance, temporarily we have to remove this load resistance. Okay, this is RL. Okay, load resistance, we have to remove this load resistance. Okay, I will redraw this figure. This one I redraw this one. I removed RL. First of all, I removed RL from terminals between A and B. I removed RL. Step 1 is calculate the resistance of this network after removing load resistance. Okay, at this time total resistance equal to R1 plus R3. Why? Because this one is on open condition. If you activate this voltage source, current will travel like this through R1 and through R3. Like this it will travel. Here no current flow. Why? Because it is in open condition. That's why I taken total resistance R equal to R1 plus R3. This is effective resistance. Okay, current through In this time we have to calculate current through R3. Okay, current through resistance R3 equal to, here R3 equal to, how we will calculate these R1 and R3, both are in series. Okay, forget about this. Okay, here this is an open circuit, and these two in series, that's why we have to apply here. Now we have to calculate current through R3 resistor. Current through R3 resistor means R equal to I3 equal to current through R3 resistor. I3 equal to I equal to V by R na, according to Ohm's law. That's why V by R. Here V equal to this one, this V voltage, and R equal to effective resistance, total resistance R1 plus R3. Okay, like this we can find out I3. Okay, now we will find out VTH. Okay, voltage across these two terminals, VTH, voltage across R3. Okay, we have to find out voltage across R3 resistor. Okay, voltage across R3 resistor or VTH equal to, here simply voltage drop across this R3 resistor means I3 into R3. I3 into R3 simply. Otherwise here we can find in another manner also, that is voltage division rule. Okay, according to voltage division rule, here we have to find out voltage across R3 resistor. Voltage across R3 resistor means total voltage into same resistance by sum of these two resistors. Okay, sum of series resistors R1 plus R3. Okay, total voltage into same resistance by sum of series resistors R1 plus R3. Like this also we can find out. Okay, voltage across R3 resistance, that is the Thevenin's resistance. Now we will move to another step, step 2. In step 2 we have to find out RTH. Okay, here in step 1 we are find out VTH. Here we have to find out RTH. For find out RTH we have to equivalent resistance of the network seen from terminals A and B. Okay, so equivalent resistance seen from A and B terminals. At the time we have to replace voltage source with internal resistance. If any current source is present, we have to kept open. Okay, I can make it short. Why? Because there is no internal resistance. I can make it short. This one R1, this one is R2. Sorry, here nothing. This one is R3. Okay, now we will see from here. We have to calculate between A and B terminals. Here RTH means it is in series with, it is R2 is series with R1 and R3. So I can write RTH equal to R2 plus R1 into R3 by R1 plus R3. Why? Because these two are in parallel and it is in series. Okay, this is RTH. Now we are find out VTH and RTH. Okay, in another step 3, we can redraw this entire equivalent circuit like Thevenin's theorem. VTH. Okay, VTH is in series with RTH. Here RL between terminal A and B. Here RL. Okay, it is a Thevenin's equivalent circuit. VTH is in series with RTH. We are already find out this one. I again connected RL load resistance to Thevenin's equivalent resistance VTH and RTH. Okay, in step that is in step 3. Okay, determine the current flowing through the RL. We have to simply apply Ohm's law. Okay, we can it is in very simple series circuit. We can now I can apply Ohm's law for find out load current. IL equal to V by R according to Ohm's law. V by R. Here V means VTH. Okay, by R means this this RTH plus RL. Okay, for find out load current, this is formula. RL equal to V by R, that equal to VTH by RTH plus RL. Okay, this one. Now we can find out voltage across load resistance. Okay, voltage across load resistance. Voltage across load resistance means potential difference across load resistance. That equal to we can apply here voltage division rule. Voltage, according to voltage division rule, voltage across load resistance, total voltage means VTH, total voltage into same resistance means RL, okay. Total voltage into same resistance by sum of series resistance. Okay, sum of series resistance means RTH plus RL. Okay, RTH plus RL. Like this we can find out potential difference across load resistance. It is about Thevenin's theorem. Thank you for watching.